Okay, for chapter 2, I'm going to have several videos. I'll have one just for notes for each section. I will also have a specific video for significant figures, and then a separate video for the metric scale. Maybe this will make things a little bit easier to navigate. All right, so section 1, we're going to talk about the scientific method, quantitative and qualitative observations, and the difference between hypotheses, theories, and models. Scientific method has been around pretty much forever. It's just a natural process that we use to solve problems. But it's been on pencil and paper ever since Galileo. He was one of the first to actually put down the steps of the scientific method and kind of analyze the way we think things through. Same steps that you've studied for the scientific method since grade school. So not a whole lot has changed. We're going to just look at the hypothesis and theory sections a little bit more thorough than what you're used to. Observing, you're going to use your senses. So you have 5 of them. You have a flashlight in your hand and you flick the switch and nothing happens. You've made an observation. So when you make this observation, more than likely it's going to be qualitative. You're going to give me a description about the light not coming on, the switches going back and forth, but nothing's happening. We could also give quantitative values. So maybe you have a voltmeter and you can test your batteries to see if they are putting out any voltage. And so then we could have a value in watts. A system. This is the specific area that we're looking at for our test, for our observation. So maybe for a dissection, you've cut open your frog, but you're only going to look at the nervous system. You're not studying anything else. There are several other parts of the frog, but all you're going to look at is the nervous system, just that one section. We could have the same thing in a chemistry classroom, so we could have a container with a reaction going on. And we could be looking at one step in that reaction. We could be just evaluating time. How long did the reaction take place? How many steps did it go through in that amount of time? So a system is just a portion, maybe of our experiment or of a lab or whatever it is we're studying. Hypothesis. The main thing about a hypothesis is it has to be testable. If you can't perform a test on it, then it's just an observation. It's just a claim, but it's not an actual hypothesis unless we can make some kind of test. Right. So parts of our test, we have to have a control. We have to have something to compare it to. This is really important when you get into biology. Mr. Hayes will give you a lab, and he won't give you a whole lot of structure. They're called guided inquiry. So your job is to figure out the steps in the lab. Well, one very important thing, if you do a lab, you have to have some results to compare it to. In chemistry, it's not a big of a deal because our control is usually a set value. So if I give you a piece of metal and I want you to calculate its density and then tell me what metal it is, well, you can put it on a scale and weigh its mass. Then you can take out a ruler and measure its volume and divide the two and you have its density. So now you can get online and you can do a search on density of metals and find a chart, and whichever one matches up with your value is your unknown metal. So a set value is usually our control. If I want you to calculate I want you to show me the steps and calculate the density of water. Well, you already know what it is. It's 1 gram per milliliter. So that value is our control. Our variables are things that are going to change. So for the density lab, our grams, our mass is going to change, our milliliters or our volume is going to change. A lot of times we use models to explain why things occur or how they occur or how they appear. We use a lot of different types. So, the first thing you think of is a globe. Well, we use a lot of mathematical models in physics and chemistry. And a theory, a broad generalization that explains a body of facts or phenomena. Theories are agreed upon statements by a large number of people that have a strong background in that area. So the example they give is the atomic theory. So atomic physicists who've all sat down, they've done experiments, and they all agree that these statements are fact. One day, we might come up with better technology than what we have now, and we might realize, wait a minute, that theory is not true anymore. So theories can change over time. And this is where a theory is separate from a law. In nature, laws will always be true. There are no exceptions to laws, and it will be true in every single instance. Theories will change over time. There are lots and lots, hundreds of thousands of theories. There's not a whole lot of laws. Less than 100 for chemistry. We won't have a whole lot of laws that we will learn in this class. All right, so here are our common steps for the scientific method. So going back to the flashlight example, I give you a flashlight and it doesn't work, so that's our observation. Communicating, so you're going to ask somebody, hey, did you get this flashlight to work when you used it? You're going to ask questions, you're going to ask other people. So now you're going to come up with a hypothesis. You're going to try to think of all the things that could be wrong with this battery. So now you test it. You open up the battery, open up the battery container, take them out, switch them around, try it again. If it doesn't work, you're going to put some new batteries in it, try it again. If it turns on, you can now come up with your theory. Okay, my flashlight didn't work because the batteries were dead. If that wasn't true, then you have to come back and say, all right, we have to come up with a new hypothesis. The batteries aren't dead, what else could be wrong? Well, maybe it's the bulb. So you take the old bulb out, you put a new bulb in, that's our test, and now the flashlight comes on. So now the theory is the batteries were fine, we needed a new bulb in our flashlight. And so that was your theory. All right, so that is the end of section 1.